We're going to work a couple more absolute value inequality problems. Here's a problem that we're going to work, and we're going to try to get a number line going as well to make sure we understand what's going on graphically. So we have 1/2 times the absolute value of 4x minus 4 plus 5 is greater than or equal to 15. So the goal here is to solve for x, and our little sub-goal is to isolate x. So that's going to be kind of our first thing we want to do. So let's go ahead and subtract 5 from both sides. We get 1/2 times 4x minus 4. We subtracted the 5 from both sides, and that should be greater than or equal to 15 minus 5 is going to be 10. I am going to multiply both sides by 2, and I should end up with, well, 2 times 1/2, those are going to cancel, so that'll be 4x minus 4, the absolute value. You can't forget that. Keep those absolute value sign right there until we're all done. And I forgot to multiply that 2 on the other side. So 10 times 2 is going to be 20. All right, now I've kind of isolated at least what's in the absolute value on the left side, so I'm going to do my branch out activity here. 4x minus 4 is going to be greater than or equal to 20, and 4x minus 4, again, I'm looking inside the absolute value, and I know that's going to be, I'm going to change the direction of the absolute value and also change the sign. I'll just write it in red like that. So I just have to solve for x for both of these. So I just made a little bit more room. I know I have to solve these two equations. I'm going to add 4 to both sides. I will get 4x is greater than or equal to 4. Dividing this side and that side by 4, I get x is greater than or equal to, that's a 24. X is greater than or equal to 6. So in a number line, that's my 0, 1, 2, 3, 4, 5, 6. I have, and we'll just do this in green. So x is greater than 6, so I'm on the point 6, and I'm greater than or equal to it. Okay. And then the second part is, of course, solving this other side. So we're going to add 4 to both sides, and we'll get 4x is less than or equal to, and this is going to be negative 16. So when we divide both sides by 4, x is going to be less than or equal to negative 4. So 1, 2, 3, 4, and let's do this in red. This will be the point 4, negative 4, and will be equal to or less than negative 4. So it is interesting to see that your center point of this whole thing is actually right here, I believe. Right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So yeah. So anyway, this is the solution. X is greater than or equal to 6, or x is less than or equal to negative 4. Those are the solutions. Let's move on and do one more problem. The absolute value of x plus 2 over 3 minus 3 is greater than or equal to 1. What's interesting is that you probably could rewrite this as x plus 2 times 1/3 minus 3 is greater than or equal to 1. That would be fine, because this third that's in the denominator of this equation doesn't really matter. Meaning it's not going to change what's inside as a positive or negative. But let's just go back and look at the problem and try to do our goal, which is really first is to isolate x. And second is going to be to solve for x. Okay. All right, so we're just going to add 3 to both sides. When we add 3 to both sides, we get the absolute value of x plus 2 over 3 is greater than or equal to 4. Okay, we have isolated the absolute value on one side of the equation, which is great. And that's really part of isolating x. Okay, now what we're going to do is do our little branch off here. And maybe our goal we should have put up here. We've isolated it already, so we'll just say solve for x is our goal. Okay, so x, let's take off the absolute value sign and say that x plus 2 over 3 can be greater than or equal to 4, or x plus 2 over 3 can be, and we'll change the sign in red, less than or equal to negative 4. Okay, we're going to multiply, let's do it in blue. We'll multiply both sides of this one by 3, and we'll get x plus 2 is greater than or equal to 12. So these will cancel. When we subtract 2 from both sides, we get x is greater than or equal to 10. So on a number line, it kind of looks like this. Here's 0, here's 5, here's 10, and we have a point here. Okay, so that's part of our solution. And let's go ahead and we'll just use red for this. Let's multiply both sides by 3. We get x plus 2 is less than or equal to negative 12. Now we're going to subtract 2 from both sides. We get x is less than or equal to negative 14. So if we were to go on the number line, that'd be 5, 10. This would be negative 10. Here's negative 15. Perhaps we need a little more room on our number line. So negative 14 is right about here. And we'll put a little red dot there and show that that is our solution. So there you have it. We solved for x. X could be x is greater than or equal to 10, or x is less than or equal to negative 14. Again, if you're uncomfortable with this, you could plug in a number. Well, you know, let's try this. Let's plug in 0 for x. What do you think is going to happen? Are we going to, is this statement going to be true if we plug in 0 for x? Let's find out. 0 plus 2 over 3 minus 3 is greater than or equal to 1. Let's see if this is a true statement. So this is going to be 2/3. The absolute value of 2/3 minus 3 is greater than or equal to 1. Well, let's put this in like terms. We know that the absolute value of 2/3 is just 2/3. Okay. Now, let's see. 2/3 minus 3 is the same as 9/3, right? Is that greater than or equal to 1? Is negative 7/3 greater than or equal to 1? No, it is not. So the point 0 is not part of the solution for this problem. So you can convince yourself also of some other points to see if those solutions work. But our ultimate solution is going to be x is greater than or equal to 10, and x is less than or equal to negative 14.